Hi guys, today we're going to learn how to do partial fraction decomposition. In this we would simplify complex fractions so they are easier to solve. This is also a really important topic in calculus, so it would help you in future. So first let's see what a partial fraction is. When one polynomial is divided by another, it makes it a partial fraction. So the first step we can do is, if our denominator is quite complex, we should first simplify this. So here we can see we can just apply midterm breaking to this like we have learned in a previous video, so we would also revise this. We can break this 3x down into 2x and x, so we can write this as x plus 2x plus x plus 2, and here we can take x common. We get x plus 2, and here we take 1 common and we get x plus 2. So we can simplify this into x plus 1 and x plus 2. Now we can replace this denominator with this value we have calculated. So we can write this as x plus 1 and x plus 2. Now in partial fractions, what you basically have to do is you have to separate all the values which you're multiplying in the denominator and give them a different variable which we would solve later. Here we can write this as ax plus 1 plus b x plus 2. Now we can write this complex fraction into this simpler fraction, but to write in this we have to find the values of a and b, so we would do just that. And for this, the first step is you have to divide both hand sides with the denominator that we have here. So if you divide this by the same denominator, of course it would cancel out. So we can just write 5x plus 6, and here you have to multiply it by this. So x plus 1 would cancel out, and we can write ax plus 2, and here if we multiply this with this, x plus 2 would cancel out, so we can write b x plus 1. One simple trick is that you would take this denominator and you would see, and this one would of course cancel out. So here in the left hand side you would only write the numerator, and in the right hand side you would see which value is being divided by this. Here it's being divided by x plus 1, so you would only cancel that value out from here and just write the rest. So here we had x plus 1, we cancel it, then we write x plus 2, and here we do the same. So now let's solve this. Let's simplify this. This we would just write like that, and here we would open the brackets, 2a plus bx plus b. Now what you have to do is you have to separate out the values which have different power of x. So here we have x power 1, these both have x power 1, and these both have x power 0. When there is no x means it has x power 0. So we will separate these out, write these separately. This one we take the x common, we rewrote this, and here we will take the values without the x. Now what you have to do is you have to take the left hand side and the right hand side and compare these. Here see our coefficient of x is 5, and here a plus b is our coefficient of x, so we would write these as equal. see this is our one equation, and here we would take the values with no x. Here we have 6, and here we have 2a plus b, and here is our second equation. Now we have to solve them to get the value of a and b. So what we would do, what it looks more, is we would take 6 2a plus b, and we would subtract this equation from that. So we would write minus a minus b. Now our b would cut off, and we would get 1 here, and we would get a here. So our a is 1, and we can plug this value in either equation and get the value of b. So our value of b, let's plug it in this one, as this one is simpler. So our value of b is simply 4. Now we would just take these values and plug them in this equation. Let's call this equation 1. I will just plug them in this equation. We can write this 5x plus 6 over x plus 1, x plus 2, 1 over x plus 1 plus 4 over x plus 2. And that was it. That's how we solve partial fractions. And we can also look at some more complex partial fractions where we would have repeated factors and irreducible quadratics. So now let's look at those. Let's take an example of repeated factors. We can take this equation as an example to x plus 3 over x squared, x minus 1